I just want to take a few minutes to talk about the Accupower products in general here. We have currently 3 drivers that we sell, some variations in the drivers depending on the customers and what the customer needs are. We also have these enormous ports. One thing that I've talked with many other loudspeaker professionals about is, in general, there's a real disappointment within the loudspeaker industry that many companies manufacture systems that, you go to here in a store, for professional audio, that store might be something like a Guitar Center or Daddy's Junkie Music or something, or for home audio, that might be a Best Buy or something like this. And you go to these stores and you listen to these systems, and they sound like okay at the showroom. And then you bring them into your home, and when you really want to take advantage of the system and really get it to do what you want it to do, they don't necessarily come through. Of course, this is all marketing and cost issues. At Accupower, we are an engineering-driven company. We're showing you what the drivers are made of. You'll notice there's 0 marketing input here. Every aspect of the loudspeakers, both the Bully Sub, which we've been selling for a few months now, and the Accupower drivers, it's simply strictly engineering-driven, as is the port tube. We currently have these available for immediate shipment. This is a 10-inch ID tube. I believe this is 17 inches long. And these flares we custom manufacture. These are spinnings. Anyway, these are powder coat, semi-gloss powder coating on these flares. Again, they're aluminum spinnings. They take the 10-inch ID and open it to a 16-inch ID. And you need a port of this diameter, of this size. Otherwise, when you power the system up, if you use some standard, 4-inch or other port, they're absolutely worthless for higher power applications. This port here we've tested, and up to 160 volts RMS into an Accupower 18-inch driver. The port is very linear. There's almost no loss out of that port. Also, I've talked a lot about the Accupower drivers on some of the videos. This is the Bully driver. The Bully driver was designed by a good friend of mine, Jesse Spence, a few years ago. The Bully driver is an excellent value, and it really bridges the gap between cheaper 15-inch woofers you can buy in the $150 price range to esoteric, higher-end woofers in the $500, $600, $700 price range, meant more for car audio or something. Those drivers have a lot of chrome and rubber rubber on the motor structures and things you don't need. The Bully is an excellent value. It has an 18-millimeter linear X-Max. I'm not talking about X-Max as it's defined by other people, but there's actually 18 millimeters of overhang in the coil. And the Bully offers a really respectable 400 watts RMS power capability. We have OEM customers, both for the Bully and for the Accupower drivers, in high-end studio monitor applications. Every one of these drivers you see here has been used in a really high-end studio application. The Bully driver is an excellent value. It's a good value if you're an audio amateur just buying quantities of one, or if you're an OEM, we actually sell the Bully subwoofer driver down to the $275 range. Many people have talked to me about the pricing on the Accupower drivers. Before we started, many people said, maybe $1,000 range is a little bit too much. But the interesting thing is, each time we sell the driver, the people feed back to us and say, you actually should be charging $2,000 for this driver. Once you actually get the thing in your hands, when you pick up a driver that's literally 40-something pounds, and it's a neodymium driver, that's kind of interesting. That takes people off guard. And then you start looking at the inner details, all the different higher quality adhesives, the construction techniques. You realize the thing's actually quite a value. In volume, these drivers, the Accupower drivers, are in the $750 to $800 range, and they're just a real steal. They're really good bargains. I'm going to talk about the metalware now. It's used in an Accupower loudspeaker. We have 3 main castings that are used in an Accupower loudspeaker, and then some supplemental ones we'll get to in a minute. The baskets are very different than a conventional loudspeaker. This is actually the 15-inch basket. And you're looking at it and you're saying, gee, it doesn't look like much of a basket. Well, that's because The heatsink of our loudspeakers is most of what a traditional basket is. This is the 15-inch basket. This here is the 18-inch basket. And then we have the heatsink. Before I'm going to talk about the heatsink more in a minute, but what I want to talk about all these is that we spared no expense in tooling these parts. Many companies who make high-end loudspeakers, they don't want to invest the money because they're worried the volume's not going to be there. They don't want to invest the money in real tooling. We didn't do that at all. We spent roughly $250,000 on tooling the parts for the Accupower drivers. Nearly every part of the Accupower driver is tooled. Virtually nothing is off the shelf. I think the terminals we did not tool, and the screws we didn't tool. Outside of that, pretty much everything is tooled in the driver. These die castings, these are die castings, and they're extremely accurate. Again, we just spared no expense here, and these were done in a very high quality die casting house. Again, that's the 18-inch, and underneath it the 15-inch baskets, if you will. This is the heatsink. Nothing like this has ever been used in a commercial loudspeaker. This heatsink has over 5 square feet of surface area, and a lot of it are these windows. There's actually a fair amount of air pumping through these windows. We ran a test where we powered an Accupower loudspeaker for several hours at 2 kilowatts RMS, and the difference between the metalware temperature and the ambient temperature was only about 50 degrees F. 50 to 55 degrees F. That was the difference between the metalware temperature and ambient temperature at 2,000 watts RMS. Nobody's ever seen that. In fact, nobody's ever seen anything like that before in a loudspeaker. What it does for us, it doesn't just give us incredible power handling, it gives us virtually no power compression. That's important. If you're in a studio application or a very high-end home audio application, you don't want your driver to start compressing once it starts getting warm. You don't want to lose a couple of dB. The Accupower drivers, for audio purposes, basically don't have any power compression. The test I told you about was actually a more or less continuous, very hard-hitting 2,000 watts. And even so, there's just very little difference between the ambient temperature and the temperature of the motor structure. Another reason for the extreme power handling you see is this hole in the middle of the motor structure, and here it is in the back. The Accupower loudspeakers, when they're in operation, are pumping an enormous amount of air through the whole motor structure. There's so much volume velocity to that flow that you can actually feel the heat 3 or 4 feet behind the loudspeaker when it's just sitting there being held. Your hand will actually get warm almost immediately when you dump a lot of power into the speaker, even 3 or 4 feet behind the speaker. Another feature of the Accupower drivers in the metalware is this copper shorting sleeve. This sleeve is full length, that is, it runs the entire length of the gap. This part in our loudspeaker does 2 very important things. It reduces distortion by reducing eddy currents in the motor structure, and it also lowers the inductance. And the lower inductance, it's designed just right. The loudspeakers, even though they're very high power, and even though they have 6-inch voice coils, they're actually flat, plus and minus 1 dB to about 500 hertz. The 15-inch driver is actually plus or minus 1 dB all the way to 500 hertz, and the 18-inch driver is plus or minus 1 dB to about 480 hertz. This enables any different application to cross over these speakers as high as you want. If you want to do a 150 or 200 hertz first order crossover with these, you can do it. If you want to do a higher order at a lower frequency, you can do that too. You're not limited. The coil, if you notice, the coil is a 2-layer coil, and the 2-layer coil in combination with this copper sleeve lowers the inductance, lowers the moving mass of the coil enough to enable a very flat response. Many high-power subwoofers simply don't have that. Many high-power subwoofers use a 4 or a 6-layer coil, an 8-layer coil even, and the resulting response is a roll-off after 70 or 80 hertz. And that's really no good for a lot of applications, and we just wanted to avoid that entirely. The motor structure itself, the magnet structure itself, is extremely simple. Again, I believe in the KISS principle. It's only 3 parts, the magnetics. This is a very large pot. It's nearly 8 inches in diameter. It's very heavy. This is what I call an inner pot. You would maybe call this a top plate in a conventional pot structure, but this thing is just so big it actually looks like another pot. I'm not sure how well the camera's picking up these features, but it's a whole other pot here. And then between them is the magnet. This is the largest neodymium magnet ever used in a loudspeaker by far. It's operating at some 90% of its capability. That is, 90% of all the flux lines that you could ever get out of the magnet are being attained. We're getting it. And 97% of all the field lines that are being kicked off from this magnet are actually in the gap. It's a tremendously efficient magnet circuit. The other thing that's very important, we talk about it more in other places in our website, another place on our website, is the magnet is operating at a very high operating point. That means there's zero probability of the magnet thermally decoupling, thermally losing its ability. It's a big problem. Many other loudspeaker manufacturers have used neodymium in their loudspeakers only to have high temperatures reached by a loudspeaker to temporarily and sometimes permanently demagnetize a loudspeaker. You lose BL. That's not the case in the Accupower driver. These are two other die castings, and this is part of what we patented in the Accupower loudspeakers. Like I said, there's a huge amount of air that moves in and out of the motor structure, and this air that moves in and out of the motor structure has to go around this part through a channel, and basically that air coming through this hole here now is forced against this surface area of the inner pot the entire length. That keeps this inner pot very cool. Obviously you have this enormous heat sink doing a very good job of keeping the outer pot, the main pot, very cool. And now this feature here, you got a lot of air pumping through the hole here, and that air is very fast along the entire surface of this pot. This keeps the inner pot cool. And it's research that I've done in my career in the past has shown that if you keep a motor structure cool, you can really increase the long-term power handling of a driver. And this feature here, a lot of people have asked us, what is this thing? When they've seen pictures of a loudspeaker from the back, had friends send them pictures or seen them on the internet somewhere, people have seen this and asked what's going on. And all that's going on there is that this feature here is simply used to mount this aluminum cup inside that inner pot. And we just use this screw to go between them, and that's all that's going on there. The screws, you can see them here. We use stainless steel screws only in the Accupower drivers. Every part in the Accupower loudspeakers, the materials were simply the best that we could use. The manufacturing techniques were the best that we could find. Hi, this is Carlos Beltran with Accupower. It's March of 2006, and we've been selling product now for 14 months, and many people have called us or written us or emailed us and said, hey, your speakers, we've gone to your website, we don't see pictures, or we don't see any, could you take some video, could you show us more of your product? When people have received our product, they've always been excited. They've always called and said, wow, these speakers are unlike anything we've ever seen before, and they're excited. So we wanted to show the public here who hasn't bought our speakers yet, show people what's involved in an Accupower driver. Right now I'm going to talk about software. First, the voice coil. This coil is one of the major features that enable these drivers here to handle the enormous power that they do. Many other speaker companies claim power handling of 1,000 or 1,500 watts or 2,000 watts, maybe even 3,000 watts or 4,000 watts. But no drivers out there take long-term, several-hour power at that level, except for the Accupower drivers. They're the only drivers that do it. And when I show you the Metalwork, I'll show you even more of why. But one of the reasons is this enormous surface area. The coil here in the Accupower driver is a full 6-inch diameter. The winding length is about 28.5 millimeters. Gives it enormous surface area. And as we'll see later, we do many other there are many other features inside of the loudspeakers that enable us to take the heat generated here and just throw it right out. I'll get into that later, but here's the coil. These are just two different dust caps. Generally, we've used two dust caps in the Accupower loudspeakers. an aluminum one and a paper one. The aluminum one is more for pro audio. The paper one has been used more for high-end home theater, high-end home audio, and studio monitor applications. This is the spider in the Accupower drivers, and many people have asked me, how do you handle the lead-out wires? How do you make sure that over the 39 millimeters of travel in each direction that the lead-out wires are going to perform well, that they're not going to wrap, they're not going to make any kind of noise, and that they're going to be reliable? Well, what we did with the Accupower standard product here is we constructed a serpentine here with the lead-out wire and the spider. We have 4 loops going between the terminal and the voice coil. The 4 loops each handle a very small percentage of the displacement. Each one of them is not under any particular stress. So the result is there's no spurious noises, there's no lead-out wrapping of any kind, and the reliability is extremely high. Accupower has been shipping product now for 14 months, and we don't have a failure in the field to date. Every loudspeaker we've sent out to a customer has been enjoyed and well loved and used continuously, many of them. The speakers don't fail in audio applications. The speakers are very, very low in distortion and very, very low in noise on up through pretty much their whole power range. So that's the voice coil. That's the spider here. That's the details on the spider. The surround is very, very important. As you can see, the surrounds are very large in both the 15-inch and the 18-inch drivers here. We actually manufacture the cone assembly here as we do the voice coil assembly. This is just the surround and the 18-inch driver. It's enormous to allow for the throw. Again, the Accupower driver's mechanical limit is 39 millimeters in each direction. The geometry of these surrounds is super critical. They're each slightly different. They've each been designed for maximum linearity through the travel and in each direction. The movement in one direction is just the same. The restoring force versus displacement in one direction is the same as it is in the other direction. That's non-trivial. Many people think that if you just take even many loudspeaker designers think that if you just take a half-roll surround and you terminate it at the land and you terminate it at the cone, that you're going to have something reasonable. In fact, that's not reasonable at all. And we're going to insert a still here of the actual cutaway of the surround. And you can see a couple of features. One is we have very large fillets on each side, both on the cone land side, on the cone attached side, and on the surround land where it attaches to the basket. They're very large fillets. That's important. The other thing that's important is that you'll notice that the height is not the same. The vertical position where the surround attaches to the basket is not the same as the vertical position where it attaches to the cone. And these different fillets and the details of the surround roll are very important to. It's very important to scrutinize every little detail. If you do so, and we used a lot of finite element analysis, something called large deformation analysis, where we scrutinize every little detail and we ensure that when the speaker comes together, that its displacement, the restoring force of the surround versus displacement, is as linear as possible over as long a travel as possible. At about 1 kilowatt of input into these drivers is where you may begin to hear any kind of audible objectionable anything. The distortion is approaching 1% at about 1 kilowatt odd order distortion. That is simply unheard of. People who buy these speakers, listen to these speakers, sometimes they A/B them against other speakers. That's the immediate thing they notice is they take an amplifier, they really power up the amplifier. Even at 1 kilowatt RMS, that level of distortion is so low that, especially with music, it's inaudible. Actually, it's inaudible with music even quite a bit higher than that. But even when you're listening to speakers alone, even with a sine wave in a box, there is tremendously low distortion from these loudspeakers. The coil and the motor structure, I'll get into that more in just a minute, that's a big part of it. And these surrounds are another big, big part of it. We spent a lot of time designing these surrounds. We also molded them at a very high quality molding company. We did not go to a typical loudspeaker cone manufacturer for these. In fact, the company we use for this has never done a loudspeaker part. They're known for some much higher quality moldings of different kinds, and we decided that was the outfit to go to, and it was the right thing to do. These parts are very accurate and very, very well made.